Hi everyone, this is Purnima Mahalingam and you're watching video lecture series on power system protection switchgears. In last series, we are discussed about nature and causes of the fault, types of fault, etc. Today, in this video, we are going to discuss about the various zones of protections. Come, let's go to the video. Here, coming to the zones of protections, first deals with first, we are going to deal with the definition of protection zones in power systems and concepts of overlapping protection zones and examples of protection zones in real power systems and protection zones for different power system components. So we are mainly focusing on these four topics. Here, coming to this, first, what happens is the protection zone is defined as the part of the power system which is protected by certain protective systems. So we know that we have a certain protective systems. So it is protected. The zone is the power system is protected by a certain power system equipment. So it is established around each power system equipment. Here you can see the basic power system zones, protective zones. Here comes it is here this is what an generating stations. From the generating stations we have transformer which is step up, and we have a transmitting stations, and we are in receiving, and we have another transformer which step down the process supply, and finally we are going to giving to the load, commercial load or whatever may be the load. So the entire power system is covered with the several protective zone, and no part of the system is left unprotected. So the entire power system is protected, because even a small part of power system gets fault or the entire system gets collapsed. So the protection is very much needed. Okay. Now, coming to here, we can see what are the items to be protected. First is a generator. So if we can see that what is a symbol of the generator protection is needed, and transformer protections where it is needed. This is what transformer protections where it is needed. And next one is transmission line. So the transmission line protection is where is needed. And the loads are motor. Finally, end is loads are motor. And we have a bus bar protections. We are the main parts. Which parts need to be protected? That is generator, transformer, transmission line, and loads are motor, whatever may be, and bus bar protections. These are need to be protected. How we are going to protect that we can see in this video. Here the neighboring zones overlap so that the no dead points are left in the protective zone. Here we can see the what this is what a generator, this is what a generator, and this is what an transformer. This is what an transformer. Here, so generator is protected separately, and the transformer is protected separately. But here we have an particular transmission line which is not protected. That is what a dead spot. Even if any fault occurs here, it also spoils both the generator and both the transformer. So each and every part in the entire power system in the transmission line need to be protected, so that we need to overlap the zone. Here in this diagram, you can see the overlap diagram. Here you can see the overlap. So generator transmission line is overlap. See here, there is no dead spot is available. Here now coming to the example for determining protective zone of simple power system. Here the each and every systems, here the generator, here the transmission transformer, this is a transmission line, and again is a generator, and finally load. So everything is here see is everything is protected. So everything is protected, not only protected because of that overlapping, everything, each and every part of an entire power system is also protected. Okay, now coming to examples on determining power system protection systems. Here we can say that here we have a generator. Here we have three generator. So the draw the protective zones of the following power systems, and which breaker should be should open the fault at P1. So which breaker should open for fault P1, P2? Here, the fault occurs in P1 and P2. Which breakers need to be open? So we have how many breakers here? We have so many circuit breakers. So here the B42 must be open. B42 must be open. And for this, B21 and B23 must be open. Then only both this generator can be protected and this generator also protected and this generator is also protected. So this is one example, one line diagram. And now coming to another diagram, here we can see the entire system for fault P1. Here the fault P1. Here the fault, the breaker B24 and B42. Here see the B24 for 24 and breaker 42 must be open. So this generator can be protected and this line is also protected. For fault at P2, here this is a fault, this is a fault 2. What happens here it is, the breaker, which breakers for breaker should be open is breaker 2-1 and 2-3 must be open. Then only this generator and this generator can be protected. Now coming to this, here is a small example for this. The following networks we have one is circuit breaker and circuit breaker opened, circuit breaker 1 and circuit breaker 3. Here we can see the circuit breaker 3 is there, circuit breaker 1 is opened and circuit breaker 2 is opened. And what happens, there were fault conditions. So for various fault conditions, we can see the various one line diagram here, and based on this, we can protect the systems. Here the protections comes under the term protected system simply protect the name according to the principle of operations or abnormal conditions. Examples, overcurrent protections and at fault protections and reverse power protections. Even the reverse powers also affect the entire systems. And the under voltage protections and under frequency protections. These are the protections. Examples. The protective schemes comprise the set of protective system and protect the scheme is named according to the protect the equipment. So the protective systems, we already know the protect the major equipments, what we have. The major equipments, what we have it is transformer need to be protected and motor need to be protected and generator need to be protected and bus bar need to be. So these systems all need to be protected. Here comes to the finally the part. What it is what it is a generator protection. So protection generator stator and here the what type of protection, differential protection is used. Here the transformer protection, here when the differential buckles relays are used. This feeders, the feeders are protections, so protecting outgoing feeders, overcurrent at fault and transmission line protections and distance and overcurrent relays are used. And here comes to the bus bar protections, so bus bar differential protections are used. And finding overlapping zones, here the overlapping circuit breakers and no protection gap. So when overlap, the protection gap is the entire system is protected. Now coming finally, these are the thing, and we are summarizing what is the need for zone and boundary conditions, current transformer, we know the overlapping zone and backup protection, and these are what main design thinking for main for safety purpose and fault impact and protect and test and relays and switch gears and types of zones, where which zones are we are protecting and what happens it is. So these are the things we are studying today. And with this, we'll end up this session and we'll meet in the next session. Thank you so much.